Today, we are going to learn a new type of finite state automata, namely NFAs with epsilon transitions. We shall start with some example NFAs with epsilon transitions, and after that, we shall formalize the definition of NFAs with epsilon transitions. So, what are NFAs with epsilon transitions? We can start with an example. Unlike all the previous finite state machines, this machine is making use of a new kind of transition, namely epsilon transition. So, what is the semantics of an epsilon transition? The semantics is that if you are in state 0, then without reading or consuming an input symbol, you can reach into state 1 or 4 by taking the epsilon transition. So, epsilon transition allows a finite state automaton to make a move without consuming an input. For example, in this machine, by just reading the simple A, you can reach into state 3. How will you reach? You first do this epsilon transition and then you do this A transition. So the input symbol processed along this path is just A. The label of the path is epsilon concatenated with A, which is just A. And in fact, to process an input, the machine should first make a move either to state 1 or to state 4, and then it can process the first symbol of the input. Here the question is, what language is accepted by this N of A with these epsilon transitions? There are two possible ways of accepting an input string. One is through this epsilon transition. If the input is accepted through this epsilon transition, then you can see that the first input symbol processed is A, because first you have to make this transition and then only you can process the first input symbol. So if this is the case, then the input is starting with A. And the other case is this. In that case, you have to come to this state before you process the first input symbol, and then if you accept, the acceptance is happening because you finished reading in the state 6. Then it shows that the last symbol read is a B. Okay, so if you accept by taking this epsilon transition, then the string is ending in B, and if you accept through this path, then the string is starting in A. So the language is the set of all strings starting in A or the set of all strings ending in B, and that's the language. Let us move on to the next example. It's a very similar example. Here the alphabet set is just A. Not that epsilon is not a part of the alphabet set. It's a special transition. You can make a transition on epsilon as well. And here the machine allows you to move into the state 1 or 4 before you consume the first input symbol. Here again the question is, what language is accepted? There are two ways you can accept. The first way is move into this component and you accept. And if you are moving into this component, you know that you have to come into state 1, then process the input symbol. So you accept epsilon, that is the string of length 0. Otherwise string of length 3 or 6, etc. So this is a multiple of 3. If you are moving into this component, then what you are accepting is a string of A's of length multiple of 3. Similarly, if you are moving into the other component, you are accepting strings whose length multiple of 5. So the language is the set of all strings X with A's said that the length of the string X is a multiple of 3 or 5. And with that, let us move on to the next example, NFA with epsilon transition, which is a little more interesting one. Unlike the previous two cases, here the machine can consume a part of the input by taking this self loop before it takes these epsilon transitions. But in order to accept, it should take either this transition or this transition because it needs to get into a final state. Now the question is, what language is accepted by this NFA? In order to accept a string, it needs to either take this epsilon transition or this epsilon transition. And if it is taking the first epsilon transition and if you accept, the meaning is that the second last symbol is a B because you need to take that transition just before the second last symbol and then you are processing the second last symbol and in this case that must be a B. So if you are taking this transition to accept, then the second last symbol is a B. Similarly, you can find that if you are taking this transition, then the second last symbol is an A. So the language is the set of all strings over the alphabet set ABC said that the second last symbol in X is either A or B. For example, suppose you are reading the input ABB, you can accept it. A, then before processing the next symbol B, you come through this epsilon H and then BB. So A, B, B. So the input process is A epsilon BB, which is exactly ABB. Epsilon is not an input symbol, it's not an explicit input symbol, but it is an extra freedom given by this machine to make a move. And now let us move on to the last example before formalizing the definition of NFA with epsilon transitions. And here is the last example, and which is an example where you have an epsilon transition from a state which is not the start state. In this example, the epsilon transition is taking you back to the initial state from the final state. The question is, what kind of a string is accepted? It's very easy to see. We can see that BA will take you from the initial state to the final state, and then the epsilon can take you back. So it can accept one or more BAs. So it can accept BA, 1 BA, 2 BAs, 3 BAs, etc. BA, then back again to the initial state. So any number of one or more BAs. And with this, we can try to formally define an NFA with epsilon transition. Maybe we can use the same example to collect the components in the definition. An NFA with epsilon transitions is defined as a quadruple capital Q, capital S, capital delta, capital F, where capital Q in this case is set 0, 1, 2, and formally it can be defined as a finite set of states, in this example set 0, 1, 2. And the next component is capital S, which is the set of final states. And what is the set of final states in this example? It's just one state 0, set 0, which is the finite set of start states, which is a subset of the set of states in the machine. And the next component is transition function capital delta. And in this example, and how delta is defined from 0, we need to define it for the simples A and B and also for the epsilon. And for the simple A, the transition is not defined from 0, it is null set. And from 0, B transition is defined to 1. And from 0, epsilon transition is not defined. So null set is the set of states that you can reach by using epsilon transition. And now from state 1, A transition is defined to 2, B transition is undefined, and epsilon transition is again undefined from the state 1. So that's the case. You cannot reach into any states on epsilon from 1. And from the state 2, A transition is not defined, B transition is again not defined, and epsilon transition is defined and it is taking you back to state 0 from 2. From 2 on epsilon you can reach back to 0, that's it. And if you formalize, you can see that the transition function capital delta is defined from a state on an input simple or epsilon, on an input simple or epsilon to a set of states. In this particular example, there are no cases in which you can reach into more than one state, but in general that is possible. To a set of states you can reach. And then the last component of the definition, which is the set of final states. In this example, there is only one final state, set 2. Capital F is set 2, and which is a subset of Q and the set of final states. And if you recall, when compared to the NFA, the definition of NFA with epsilon transitions differs only in one case, which is in the definition of the transition function. And the only difference is that you can make an epsilon transition. From a state, you can either read an input and move, or without reading an input, using this epsilon transition, you can move maybe into one or more states or 0 or more states. And that is the formal definition of NFA with epsilon transitions. And a string is said to be accepted by an NFA with epsilon transition if there exists a path from the initial state to any one of the final states for the input string. And remember that in between, the machine can make an epsilon transition without consuming an input. And that's all. Thank you.